Okay. So this is basically a review of organic chemistry. It's hard to point out yung exact pages sa book kasi in the book in detail to discuss, and I just got the particular topics that is needed for the discussion of biochemistry. So parang compressed ano to, discussion ng organic chemistry, and it's difficult to find the exact pages kasi may mga pages na pinagsama-sama ko na yung discussion. Okay? But anyway, the all the topics are there. You just need to read through the text. Okay? So in biochemistry, you have this can you hear me, guys?
Yes.
Okay. So in biochemistry, you have compounds that are made of carbon to carbon bonds. So the bond between these biomolecules, uh, the need to understand how this bonding occurs between the atoms of these molecules is important. Okay. When organic chemistry was first used, or the term organic chemistry was used, usually you have complex compounds, complex molecules, and these are composed of carbon to carbon bonds. So that's why when we talk about natural things, natural products from the plants, vitamins, and things from nature, we usually call it organic, right? But nowadays, we are able to actually create more complex compounds that are actually, they can be deadly, they can be harmful. So the term organic chemistry, when you use this the definition, the study of carbon and carbon to carbon compounds, it does not mean that these compounds are safe. Okay, so in synthetic organic chemistry, for example, we try to imitate natural products that come from plants and animals, but also in that kind of organic chemistry, we're able to build uh, more complex, more deadly compounds that can be used as chemical weapons. So don't be confused by the term organic chemistry. It does not mean that all of these chemicals are natural. Okay, but since when organic chemistry came about, all the complex compounds came from living organisms. But nowadays, we are able to create those compounds using artificial methods. Okay, so we go back to the idea that in order to understand the bonding between carbons and other atoms or elements, we just represent the outermost layer called the valence electrons. And you have 4 electrons in the outermost. So if you look at the periodic table, carbon has a total of 6, but the 2 are in the first level. In the outermost level, you have 4. And carbon wants to have 8 electrons to be stable. So what it does, it will share with another atom or another element so that it's able to complete the 8 electrons. So carbon is able to form 4 covalent bonds. So once they share with another atom or another element, they have now they have now a shared pair. So you call this a covalent bond. So a covalent bond is made up of two shared electron pairs. Okay. And this can be another carbon, it can be oxygen, nitrogen, etc. So in organic compounds, your carbon has 8 electrons. They want to achieve 8 electrons in its valence shell once it is covalently bonded with other elements. So what are the characteristics of these organic compounds? Because of the nature of these covalent compounds, they are nonpolar, meaning they don't have regions of electron density like water. We discussed last time in water, the you have bond pairs, you have non-bonding pairs. Because of the non-bonding pairs or the lone pairs, so you have regions of electron density, water is polar. And in organic compounds, since most are made up of carbon and hydrogen, this is what makes it almost non-polar. But not all organic compounds are uh, non-polar. Okay, even soap is considered an organic compound, but there's a region in soap that is polar, and there's a region that's non-polar, and that is what helps soap uh, clean objects. Okay, and they have low melting points, meaning they easily melt. In terms of liquids, they're easily volatile, meaning they can easily turn into gas. So that's because of the weak intermolecular forces. So the forces between molecules are weak. And they react slower than ionic compounds due to the strong covalent bonds between atoms. So the bonds between each atoms in the molecule itself is very strong. Compared to ionic bonds, for example, salt, when you dissolve that in water, the sodium ions and the chloride ions separate because of the interaction with the polar water molecules. In organic compounds, they don't dissociate because the bonds between the atoms are covalent. Okay. In organic chemistry, so it's not enough we write down the formula. Okay, siguro if you remember the formula of glucose, it's C6H12O6, or the formula of sucrose, C12H22O11. That's just molecular formulas. Okay, in organic chemistry, we need to draw everything. So you call that a complete structural formula. Okay, so we need to draw a 2D model that shows how the atoms are bonded to each other. An example is methane here. So the molecular formula of methane is CH4, but we have to draw the structural formula in order to understand how these atoms are arranged. So we draw the pair of electrons as a short line. So each line represents a pair of electrons. This is a shared electron pair. Okay? So if you think of in terms of two dimensions, you might think it's just it's the angles are 90 degrees. But if you want to maximize the distance between the hydrogens, think of it in terms of the corners of a pyramid. So there's much more space if you represent that in 3 dimensions. So that becomes what you call a tetrahedral structure, meaning the hydrogens point to a corner of a pyramid. So the angles between them are maximized. Okay? But if we're not interested in the angles, we can of course just draw it this way. Okay? So, for example, the molecular structure of methane is CH4. You draw carbon as the center and then hydrogens on the peripheral. And you draw the line or the covalent bond between them. For chloroform, that's CHCl3. So you have 3 atoms of chlorine, 1 atom of hydrogen surrounding carbon, no? So in molecular formulas, usually you have carbon as the center, or if you have 2 carbons, they're usually connected to each other. So for ethane C2H6, you connect carbon to another. And since you know that you need to form 4 bonds surrounding carbon, then the rest will be hydrogens. So take note that in all of these examples, carbon has 4 bonds, 4 covalent bonds. So there are types of bond. So when you have a one line, it's called a single covalent bond. So they share a pair of electrons. So that's 2 electrons. So a double bond is possible. So now you have 2 pairs of electrons. That makes it a total of 4 electrons to form a double bond. So take note that the angles, the molecular geometry will change because of the double bond. And it's possible, of course, for the carbon to be triple bonded, or you have 3 pairs of electrons with another carbon or with another atom. So types of compounds. When you have 4 single bonds surrounding the carbon, you call that a saturated compound. So saturated hydrocarbon. Okay, organic compounds in which carbon atoms are bonded by single bonds. So example is methane. Once you have a double or triple bond, you call that unsaturated. So that's compounds where carbons have double or triple bonds. So example is ethene. Okay. So organic compounds can be classified into groups with related structures and properties. So when you have similar groups, it has usually it has a similar properties, and if you increase the molecular size, the intermolecular interaction between each molecule increases. So as size of molecule increases, the boiling and freezing point increase. So you call this a homologous series of hydrocarbons once you add more carbons to the compound. You have some properties that are the same within that family. Okay. So what are hydrocarbons? So these are organic compounds that consist of only carbon and hydrogen bonds. Okay, so it is the backbone of most of the organic compounds. You have carbon and hydrogen, and then the other elements, they redefine what kind of group that these compounds have. Okay, so when you say hydrocarbon, it's composed of hydrogen and carbon because it's hydrocarbon. Okay, do you have any questions so far? Yes, question.
None.
Diba all elements po should have 8 electrons except hydrogen? Yes, yung smallest hydrogen and helium, because they have a maximum of 2 electrons kasi pinakamaliit sila, no? Yung innermost shell niya is 2 electrons. So it can only hold 2. So hydrogen and helium is the only exception. And as we will discuss, hindi pala na tayo mag-laboratory. Yung ibang structures, they can violate this, what you call the octet rule. Okay, so as much as possible, all atoms react in such a way that they want to have 8 electrons in its valence shell. So you call that an octet rule. And there are violations. For example nga, this hydrogen and helium, they only have 2. And then you have other compounds as well that do not complete the 8 electrons that is needed in the that surrounds them, no? So they are few and far between. So for the most part, especially for organic chemistry, the atoms, they want to have 8 electrons around them. Okay, so we represent the shared electron pairs as lines, as shown here. And then you have also electron pairs that are not shared. So those are called lone pairs or non-bonding pairs. You still count them in counting the electrons around the atom. Okay, any other questions? Oh yeah, that's general chemistry. So yun ba yung alkaline, so alkaline metals, alkaline earth is in group 2. But yeah, we don't have time to discuss all of these details kasi nga limited yung time natin. But if you have studied general or inorganic chemistry, there are certain types of family in the periodic table. Okay, any other questions? Okay, so if there are no questions, I will give you the link to the, patapos na tayo, 2 minutes na lang natitira. I will give the link in the chat. Okay, so it's around 1 hour and 15 minutes. So isasama ko na yung mga break or gusto nyo balikan yung hindi nyo na maintindihan. So you have your book with you if you have a copy of the ebook. Tapos tingnan nyo lang sa topics. Tapos kung may malabo, you can go back. So I'll give siguro around 10:30. Come back to class. We'll have the Zoom link again para to test your assessment, test your comprehension of knowledge. Okay? So may kasama na dun yung break kasi yung around around 1 hour and 15 minutes yung mga videos. So I'll just give you the link sa chat kasi patapos na yung time natin. Okay? So I'll just give the link sa GC natin. Okay? So I will end it here.